In this video, we are going to look at this example. A particle of mass 2.0 times 10 to the power of minus 5 kilograms and charge plus 2.0 microcoulomb approaches a fixed charged metal sphere with charge plus 10.0 microcoulomb. Initially, the particle has a velocity of 150 meters per second towards the center of the sphere, and it is at a distance of 50.0 centimeter from the center of the sphere. Assume the fixed charged metal sphere has a uniform charge distribution, and the charge of the particle does not affect the charge distribution of the fixed charged metal sphere. This event is happening in a vacuum. Calculate the distance from the center of the fixed charged metal sphere at which the particle comes to rest. To do this question, we use the conservation of energy. The total energy of the particle is the sum of its kinetic energy and its electric potential energy. At its initial position, let us call this position 1, we can write the total energy of the particle as E1 equals to EK1 plus EP1, where the 1 stands for position 1, which is simply the initial position. E1 is the total energy at position 1, EK1 is the kinetic energy at position 1, and EP1 is the electric potential energy at position 1. At the final position, which we are going to call position 2, the total energy at position 2 is E2 equals to EK2 plus EP2, where the 2 stands for position 2, and E2 is the total energy at position 2, EK2 is the kinetic energy at position 2, and EP2 is the electric potential energy at position 2. Based on the conservation of energy, we have E1 equals to E2. First, we calculate E1, which is simply E1 equals to half mv1 squared plus capital Q small q over 4 pi epsilon naught R1, where capital Q is equal to plus 10.0 microcoulomb, which is the charge on the metal sphere, and small q is equal to plus 2.0 microcoulomb, which is the charge on the particle. R1 is equal to 50.0 times 10 to the power of minus 2 meter. M is simply the mass of the particle, which is 2.0 times 10 to the power of minus 5 kilograms. V1 is equal to 150 meter per second, which is the velocity of the particle at position 1. And epsilon naught is the permittivity of free space, which is equal to 8.85 times 10 to the power of minus 12 farad per meter. If we take all these values and substitute into this equation, then we should obtain E1 as 0.5846 joule. Then we calculate E2, which is simply E2 equals to half m v2 squared plus capital Q small q over 4 pi epsilon naught R2, where R2 is the distance of position 2, where the particle comes to rest, from the center of the metal sphere. Since it comes to rest, its speed is 0 at position 2, and therefore V2 is equal to 0. Substituting these into the equation, we get E2 equals to 0.1798 over R2. Since E1 equals to E2, we have 0.5846 equals to 0.1798 over R2. And solving for R2, we get R2 equals to 0.307 meter, which is equal to 31 centimeter to 2 significant figures.